power to a power. So this is an example of a exponent rule. So power to a power, sorry, is different than like basis. If you look at this example here, why it's called power to a power is I got x to the second, then the parentheses, and then another power. Okay, so you can see I got the two powers next to each other. So my base here is right here. This is my base for the 3. X to the second is the base of the 3, and the x is the base to the 2. So this tells me I have 3 of this particular base. So that's what I really have, right? So now each of those x to the seconds, right, is its own x, and so I got 6 of them. So I go to my multiplication of like bases rule, and I would just add all these powers together. Okay. So what we're going to do is we're going to kind of same thing. We'll look at the long way, and then I'll start to show you a shortcut here. So let's look at another one. So this tells me I've got 6 x to the 6 is the base to the 4. So that means I have 4 x to the 6. That is all multiplication of like bases. So in this case, I would just add all the powers together. So 6 plus 6 plus 6 plus 6. All right, gives me x to the 24. Okay. So my base for the 2, this 2 is on the x to the 11. That means I have 2x to the 11s. So that's multiplication of like bases there. All right. So hopefully you can kind of see that there is a shortcut here. And even something simple like this, there's 3 of them, and that's x to the third. Okay. Um, so it tells me I have 4 100ths, right? 4 x's to the 100. That's the multiplication, all right, of like bases. So let's just add all those up, and I get x to the 400. Okay. So in this case, just looking at the example here, x to the 2 to the 5th, that means I have 5x to the 2's, giving me x to the 10, right? 2 plus 2 plus 2 plus 2 plus 2 is 10. All right. So now in this case, when we start to add coefficients in there, it gets a little trickier here. So this 4 right here, okay? So just keep in mind here that because of the parentheses, I have 3 of everything in the parentheses. So there's really 3 of those, right? So that means I need to multiply all those 4's together as well as the x's. So 4 times 4 times 4, then I have 3x squareds. I get 64x to the 6th. Okay? So this tells me I have 2x to the 6th as a base. All right, so I got to multiply the 4 2's together and the 4x to the 6th together. So it gives me 16x to the 24. This tells me I have 7x to the 8th. All right, so I multiply the 7's together. I multiply the like bases of 8 to the x, 8 to the x, and I get 49x to the 16th. Okay. So now, what is that? I'm going to do the shortcut here. Okay, so basically, if you noticed in the last example, is that you can just multiply the exponents. Okay, so this looks like distribution, but it's really not. So here's the shortcut. Ready? If you have a power to a power, you can multiply the exponents. Now, this 8 has a 1 on it, so it's got to get multiplied by a 3, right? And the 5 is going to get multiplied by the 3. So I get 512 x to the 15. So you're going to multiply the exponents, okay? And if there's a coefficient, if there's a number, there's a 1 there, you got to multiply it by that particular number. So in this case, okay, I'm going to multiply all the exponents by 4. There's really a 1 on this 2 right here. So that gets multiplied by a 4, okay? And then I'm going to actually multiply the 2's out. So I get 16x to the 24 y to the 20. So you're multiplying the exponents, okay? Same thing here. I have a 1 right here. I'll multiply all the exponents. And there you go. I had a w to the 9, multiply that times 2, x to the 8, multiply that by 2. All right, the exponent, not the number, the exponent. There's my final answer.